it's not Pi Day anymore. It's a Monday special.
I see. But if you like pie in the morning yesterday, you would still like pie in the morning today.
I would like it.
I'm here for
everybody skipping the day?
Yep.
I guess so. Someone told me it was senior skip day, but that should be this much paid. That's where my
Okay, if y'all would get out the circuit I gave to you yesterday, and number today's handout is 107. You could do those two things during the minute of silence. I'd appreciate it.
Good morning, FHS. Today is Friday, March 15th, 2024. Would you please join me in a minute of silence? Please stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you and have a great day and a wonderful spring break.
All right, so after our test yesterday, I had mentioned we are moving into the last unit, so there's another 4, 5, 6 skills that we need to get down before we can focus 100% on AP review. So one of those was L'Hopital's rule. So in a few minutes here, I'll let you ask some questions from any of those that you struggled with. But your AP exam will probably have a question on it that you have to use L'Hopital's rule. But also your AP exam will have a bunch of limit stuff on there that you're welcome to use L'Hopital's rule on. So mostly it's just a new tool to help you with limits if you don't remember or you struggle working them the way that we did at the beginning of the year. But I know some of you guys will have less questions than others, so let me go ahead and introduce the one I want you to practice today first. That way, if someo's asking some questions from the L'Hopital's rule circuit that don't apply to you, you can at least be working on today's and be productive. Okay, so this question type, the first half of it is actually pretty intuitive from what you already know. It's just one more arithmetic step. And then the other half is questions that are kind of framed kind of differently. So we have talked a lot about this semester trying to find the area under a curve. And so we talked about if you wanted to do that, that is one of the main applications of integration. Okay, so if I wanted to know the area under this curve, I could integrate it from A to B and I would know how much area this was. Likewise, if I had a second function like this, I could figure out the area under his curve doing the exact same thing. I'll call it g of x. Okay, but what we are going to be practicing on this circuit is trying to find the area that's trapped in between those two. So if I know how much area all of this is the red stuff, and separately I know how much area all of this stuff is, the purple stuff, how can I use those two numbers to find out just the area in between them.
Find the difference between.
Right, you just have to subtract them. So if you can find area under a curve with integration, which we've been practicing for months at this point, well, maybe not months, but close to months. You can find area under a curve by just taking the full area minus the area that's not between the curves and then subtract that. So usually I would just write this as one big statement instead of two small statements, but I'm just kind of splitting it up for you. This is the same thing as this. So when we work it this way, again, this is the one that should be fairly intuitive to you. You should know how to find this, you should know how to find this, and just seeing that subtracting those gives you the stuff in between it. But when we do this, you really want to frame this in your head as top minus bottom. You want the top function first, then subtract the bottom function. If you do bottom minus top, you're not going to get the same answer. So, well, you'd get the same number, but it would be negative, which is not what you want. Okay, but occasionally, this one's a little bit harder for me. This one's not as intuitive, but occasionally you might have like, I don't know, something like this. Let's say A to let's do A to B here. These are a little harder for me to make up, but so here could be f of x, here could be g of x. Okay, this is a bad example too. Hold on, let me think this through a little better. I'm trying to come up with a good example. Well, I'll just steal the one that I have on the daily meme. Let's say, no, f of x looks like this, and g of x looks like this. The problem with this one is, if you want to find the area between these two, like this, and we'll just assume that they're cut off by some other lines as well, top minus bottom doesn't make sense, because this one is not always on top of this one. So instead, you need to think of these questions as the rightmost function minus the leftmost function. Right minus left. Now, one other thing to this, and you may want to jot this part down on the top of your page, but if you're doing top minus bottom, you should be integrating with respect to x. These things should be in terms of x. Like x squared, 3x, x cubed, things in terms of x, and a and b need to be the x values. How far left and right you're trying to find the area between. But when you're doing right minus left, it's going to be dy every time, dy, which is your hint that the right and the left function need to be in terms of y. So instead of x squared, x cubed, 1/2 x, you want it in terms of y. A y, y squared, square root of y, just y stuff. If you're integrating with respect to y, you want this stuff to be y. And your bounds, a and b, need to be y values. So from the lower y value to the upper y value. So again, if there's one always on top of the other, you can think of it as top minus bottom, dx. This stuff should be in terms of x. These bounds should be the far left and far right, x bounds. If one function's always to the right of the other, do right minus left, dy. So that means this stuff needs to be y stuff only, no x's, and the bounds need to be the lowest y value to the biggest y value, not x values. Now, usually, you guys know I try to make our I try to pick out memes that, daily memes that I think are kind of funny and relate to stuff we've been talking about. But this one was just so good, as it's just a clean little example of what I was talking about. Here's a top minus bottom. One's always on top of the other. So top minus bottom, dx. The AB values determine the left and the right. Those determine the bounds. But if instead you have right minus left, one is always on the right, one's always on the left, do right minus left. Notice they did dy. They have those in terms of y. And then the bounds would be c to d is what they're calling it. C to d would just be the lowest y value to the biggest y value. So that one little picture there just kind of summarizes the two approaches that you should have. So again, as people ask questions from the L'Hopital's rule circuit that you just don't need help with, go ahead and start on that circuit, please. The first question doesn't even have anything to do with calculus, and then the couple after that just ask you to find area under a curve, just like you've been doing, not even between two curves. So I don't think it really steps up too much until question 4 or 5. So, and then of course, once I answer and exhaust all the questions you guys might have about the L'Hopital's rule circuit, I will also help out with the new one today. But this is one of those things they always ask on the AP exam, so you need to get some practice in. And of course, this stuff will be on the last big test. So, also, I haven't talked about that too much, but we do have one more big unit test, so probably a 50-point test would be my guess. But I will do lots of small mini quizzes over some of our AP review. So those won't be big points, but they do add up over time. So, and those will count as major points. So there will be more opportunities, but you still want to finish as strong as you can. Also, I think once you get to like question 6 on today's circuit, I think I have all of them worked out as videos after that.
Is there any way I can finish the test?
Not right now. You need to do this. If you finish this in class, then that's fine. Sorry. Give me just a second. I was trying to find my copy of my L'Hopital's rule handout. Well, I guess I don't have it. That's okay. Okay, so the only reason I did not take up the L'Hopital's rule circuit today is I couldn't take it up for my A-Day classes because we weren't in our classroom that day, and I already had couple thousand papers I was trying to manage and juggle. So I will ask for this one after we come back from spring break. But again, I know you didn't have a ton of class time, so you may have had some questions. So you'll have to tell me. Again, I couldn't actually, just let me have just a second here. It'll be easier if I find my copy because I'll know what question you're talking about. Should be right here somewhere. Okay, so which ones from the L'Hopital circuit did you have trouble with?
Can you do the fourth one down on the left on the first page?
This one?
Yes.
Okay, to me this was number 17. Okay, now this is an example of a question that you could use L'Hopital's rule on, and I'm not persistent enough to finish the question this way. But here's what you would have to do with L'Hopital's rule. You would need to plug this in, see that you get infinity over infinity. So that's how you know you can use L'Hopital's rule. So we could start off by taking the derivative of the numerator over the derivative of the denominator. But then when you plug it in again, it's still infinity over infinity. So you can do L'Hopital's rule a second time. You can do it as many times as you need to, really. But you can take the derivative again. I don't know, 21 times 6 would be 126, I believe. But then if you do direct substitution, it's still infinity over infinity. So you have to use L'Hopital's rule again. Do you see how I'm going to have to use L'Hopital's rule 5 more times to get that down? So you can do that. The numbers are going to be pretty big, which is going to be hard to do without a calculator, but if you're persistent enough and then you reduce that fraction in the end, you'll get the answer. But there's a much smarter way to do this question. So this is what I would hope that you would catch. If you're interested in the far right or far left of a graph, that's like horizontal asymptote. And because this is a rational function, you can just apply the three horizontal asymptote rules that you learned in Algebra 2 and Pre-Cal, and you need to know for the ACT. One of those rules says that if the degree of the numerator equals the degree of the denominator, the horizontal asymptote will be at leading coefficient over leading coefficient. -1/3. So, again, L'Hopital's rule works, but that doesn't mean it's always the smartest. So, also notice in question 3, is your number 3 the bottom right?
Yes.
Yeah, so you can do L'Hopital's rule there, and it's not such a pain, but you could have also just done the horizontal asymptote rule on that question as well to get the same answer. So, still in your interest to use those horizontal asymptote rules, even though L'Hopital's rule works. Okay, did somebody have something else to ask about 17 before it goes away? Okay, just to try to keep it open before I give anybody a second chance, I'll make sure that everybody has had a chance to ask one at least. So, others from yesterday's L'Hopital's rule? All right, did you have a second one?
This is the 4th on the back page on the left.
4th on the left. This one?
Yes.
I have this as number 16. Okay, so this one, and actually the question above it, both of these can be tricky if you are in L'Hopital rule mode and you're just instantly taking derivative, instantly taking derivative. You have to understand that L'Hopital's rule only works if it's indeterminate form. One of these. There's other indeterminate forms, but you would learn those in other calculus classes. But this one, so if you just start off taking the derivative of the numerator and derivative of the denominator, you're on the wrong path already. You should just do direct substitution here, which gives you pi in the numerator. Pi in the numerator is certainly not an indeterminate form. That's why L'Hopital's rule doesn't work on this question. It'll give you a number, it's just not going to be the right answer. And then when I plug in pi over 2 down here, this ends up being the sine of 0, which is 0, and a number other than 0 divided by 0, we say this is undefined, which means that the limit does not exist. It was the one that didn't exist. But again, the lesson you need to get out of this is, my guess is you probably took the derivative of the numerator and then took the derivative of the denominator, because that's what you had to do on almost every one of these questions. But L'Hopital's rule has that hurdle first. whole L'Hopital's rule does not work if it's not indeterminate form. So we didn't even need it for this question. Okay. Anybody else find a different one while I was going over that one? Yeah.
Number 10 on the back.
Number 10 on the back, the bottom left.
Yes.
Okay, so number 10 on the back, again, you always need to make sure that L'Hopital's rule even applies. So plug in E, you get 3 times 1 minus 3 over E minus E. So you end up with 0 over 0. So that tells me indeterminate form, L'Hopital's rule is fair game. So one thing to note here, we're not taking the derivative of this whole thing. If we took the derivative of the thing as a whole, we'd have to use the quotient rule. L'Hopital's rule just lets us do the derivative of the numerator first over the derivative of the denominator. Now remember, E is just a number. So just like the derivative of negative 3 is 0 because it's a constant, the derivative of E would be 0 because it's a constant. Once you take those two derivatives, you need to try direct substitution a second time. And it looks like we end up with a negative 3 over E. Did you have something more specific on that one, or no? Okay. $11.
How did the derivative of E about
How did the derivative of E what?
like how did that get a negative 1?
It didn't. The derivative of this is negative 1. What's the derivative of negative 3?
0.
Because it's a constant. E is a constant too. E is a number, not a variable, so that also went to 0. And there you can see them. You said number 11? Okay. Number 11, well, first let's make sure we're talking about the same 11. This one? Okay, so before I can assume L'Hopital's rule works, we need to do direct substitution here. If I plug in 0, this would give me 3 to the negative 2, which is like 1/9. So the numerator certainly goes to 0, the denominator certainly goes to 0, and so L'Hopital's rule is fair game for this question. Now, the derivative of the denominator is nice and quick, but the derivative of this is just something that we don't use quite as often. So this is why I suggested writing this one on the top of your page before you guys left yesterday. But if you can remember, the derivative of e to the x is e to the x times natural log of e. And natural log of e is just 1, which is why we don't ever refer to that when we take the derivative of e to the x. But if you understand there's a natural log of e there, it makes any other exponential function the same idea. So the derivative of this negative 1/9 goes to 0, but the derivative of 3 to the h minus 2 would be a 3 to the h minus 2 times the natural log of 3. Now I try direct substitution a second time, and I get 3 to the negative 2 times the natural log of 3 over 1. And 3 to the negative 2 could move to the denominator and become a 9. So that's what I got for number 11. Again, I know that you guys don't use this one a lot. I think I showed it to you probably the first day we talked about derivatives, but I understand that you don't practice it a lot. But it is one that you'll need to memorize before the AP exam. You don't want to miss a question just because you don't know that one derivative. So, okay, was there something more specific? No? Okay. Okay, if y'all got more, go ahead and keep them coming. First one on the right, page 2. This one? Okay. I had this one down as number 4. Okay, so first we need to make sure L'Hopital's rule is even needed. So direct substitution gives me 0 on top. Natural log of 1, what is the natural log of 1? 0. So because 0 over 0 is one of the indeterminate forms, means that the answer to this could be anything. Could be 0, could be undefined, could be 5 over 2, could be 71. We don't know without more work. But L'Hopital's rule says take the derivative of the numerator, which would be 2a, over the derivative of the denominator, which would be 1 over a, and then try direct substitution again. If it's still an indeterminate form, try L'Hopital's rule a second time, or a third time, or as many times as you need to. But now it looks like it'll work out. If I plug a 1 into this, I get 2, and if I plug a 1 into this, 1 over 1 becomes 1. So in the end, I ended up with just 2. Okay, anything else about that one for anybody? Okay.
Did you do the fourth one down on the first page? On the right side.
1, 2, 3, 4. This one?
Yes.
Oh, I was hoping you wouldn't ask this one.
That's why I asked.
Okay. What number do you have it as?
I didn't get there.
Okay. I have this as the last question, number 22. And I think they saved this one for the end because it is pretty messy, unfortunately. So if I plug in, well, again, we always have to make sure that L'Hopital's rule even makes sense here. So if I plug in 0 into this, integrating from 0 to 0 would be 0, minus 0 goes to 0. And in the denominator, the cosine of 0 is 1. You square that, it's still 1. Minus 1 goes to 0. So that means L'Hopital's rule should be able to help us with this. But one thing that makes this question a little bit harder than the rest is the derivative of the numerator and the derivative of the denominator are both harder. In fact, the derivative of this part of the numerator, you have to remember the second fundamental theorem of calculus. The derivative of an integral, this x squared just gets plugged in and becomes sine of x squared. But because the derivative of the upper limit is not 1, you have to multiply by its derivative for chain rule. Minus the derivative of x squared would be 2x. Now again, you're really supposed to know this one for other questions, but I realize that's a little bit harder. Are you okay with that part? Okay. Then down here, you have to remember with trig functions, sometimes you guys don't read this exponent correctly. Cosine squared, this means the same thing as this. It's just with trig functions, we put the squared here instead of outside of that, because if we put it outside of that, it looks like we're squaring x and not squaring cosine. That's important because to take the derivative of this, there's going to be some chain rule. The first step would be power rule. Bring the power down, lower the power by 1. Then you have to take the derivative of the inside, which would be negative sine x. So if you don't handle that exponent correctly, it's hard to get that derivative correctly. There is a chain rule step in there. Power rule, chain rule. Bring the power down, lower the power by 1, then take the derivative of the inside, which is cosine x. And then the derivative of negative 1 would be 0, so I don't need to keep up with that. So that's the first big hurdle on this last question, is the numerator and denominator were both harder derivatives. Now when I try direct substitution, this goes to 0, because I know this goes to 0. 0 times anything is 0. This goes to 0. and plugging in 0 down here, the cosine of, or I'm sorry, the sine of 0 is 0. So 0 times whatever that stuff comes out to be is still going to be 0 over 0. So unfortunately, L'Hopital's rule once is not enough. We have to do L'Hopital's rule a second time. So up here, I'm going to factor out the 2 first, and then I'll take the derivative of x times the sine of x squared. Now, that's got to be product rule because it's x times something. So I could take the derivative of x with sine of x squared left alone, plus I can leave x alone and take the derivative of sine of x squared. The derivative of sine something would be cosine something. And then because of chain rule, there's an inside part in here, times 2x. Then the derivative of this part would just be a minus 2. Okay, and then the denominator has a constant as well, so I'm going to take out the negative 2 first. It just simplifies it for me. But to take the derivative of cosine x times sine x, we've got to use the product rule a second time. The derivative of sine would be, or cosine would be negative sine. So derivative of this with this left alone. Then I'll leave cosine alone and take the derivative of sine, which would be cosine. So this had a sine times sine, and this had a cosine times cosine, so I just replaced those out. Okay, now that I've done L'Hopital's rule a second time, I can try direct substitution again. And it looks like we get 2 times, this would go to 0. 0 squared is 0, the sine of 0 is 0. All of this goes to 0 because I've got an x in there. So if I plug 0 in here or here, all of this goes to 0. Minus 2 over negative 2 times, plugging in 0 here goes to 0 because the sine of 0 is 0. Plugging in 0 here gives you 1, and 1 squared is 1. So in the end, I get a negative 2 on the top because all of this went to 0. And down here I get a negative 2. Those reduce and give you a final answer of 1, which loops you back to the beginning of the circuit. So again, I think they saved this one for the end just because it was a little bit tougher, but you guys should be able to take these derivatives. This one you need to be careful about. This one's the second fundamental theorem, which you need to know anyway. But on top of that, L'Hopital's rule once was not good enough. You had to do it a second time, which forced you to use product rule here, and product rule here. So that's why that was definitely the hardest question. But that would be a good one for you to try again now that you have seen it worked out. Okay, is any of that too quick, or any of it you want to clear up real quick? Okay. Okay.
Makes sense.
Huh?
Makes sense. Really confusing though.
Yeah, and it's, I mean, I have 2 copies, so I have one from probably last year and one I redid this year. And I mean, obviously I know all those steps, but it took me about 3 tries this year to do it without making a mistake. Because I knew what the final answer was, and I kept getting like -1 instead of +1, and just long questions like that are harder to do carefully. So sometimes trying to squeeze it into these little boxes, you're making it harder than it needs to be. So using more space makes it a little easier to keep up with. Okay, so last chance. Anybody who has not asked a question yet today, to give you a chance before I give everybody else one more chance to. Okay, anybody who has not asked, or I'm sorry, anybody who has asked a question, have any others you would like help with? Yes. 12? Let's see. 12 was top left, the back page. Okay, so for question 12, let's go ahead and start plugging in 3. We would get 0 plus the sine of 3 pi. So you got to use the unit circle here, but here's where 1 pi is, 2 pi, 3 pi. At 3 pi, sine is 0 also. So the numerator goes to 0, and plugging in 3 into the denominator gives you 1/3 minus 1/3, which is also 0. So sounds like L'Hopital's rule might be helpful on this question. So we'll take the derivative of this, and for this part it's just going to be power rule because the inside has a derivative of 1. I don't have to worry about chain rule. So just bring the power down and lower the power by 1. Then the derivative of this piece, the derivative of sine something, is going to be cosine something, but this one does have chain rule, so times pi. And then down here, this derivative, the derivative of negative 1/3 would be 0, but the derivative of 1 over x, you need to slow down and be a little careful about. That's the same thing as x to the negative 1. So if I do power rule on it, bring the power down and lower the power by 1, it would look something like that. Okay, so now that I've applied L'Hopital's rule, I'm going to hope that direct substitution will work so I don't have to do it a second time or a third time. So if I plug this in, the denominator becomes negative 1/9. So I can already tell I'm close to the final answer because that's certainly not an indeterminate form. Plugging 3 into the numerator gives me 2 times 0 plus pi times the cosine of 3 pi. So there's another unit circle question. Think about where 3 pi is. Cosine there would be negative 1. So we end up with negative pi over negative 1/9. So that's like negative pi times the reciprocal, which comes out to be positive 9 pi. My guess would be, was it the unit circle pieces, like sine of 3 pi, cosine of 3 pi? Is that where you had issues?
I said the derivative was for x was ln of x.
Oh, okay. Yeah, you have to, once you guys learn integration, you have to be real careful about which direction you're heading, especially sines and cosines, like, you know, derivative of sine versus derivative of cosine versus integrating sine and integrating cosine. But yeah, you got to try to keep those two separate. Okay, anybody else? Okay, so I'm going to post all of those to the website, so if you feel like you need to hear them again when you come back from spring break, if you need a refresher on those that you struggled with, that will be quickly accessible. So give me a few minutes to do that, and then I'll start to come around and see on the area between two curves where you guys are getting stuck and having issues and what we need to talk about on the board. And I'll switch it back to the agenda so you can see that the graphic there in the middle that summarizes the two approaches you should be using. Yeah. Sign out and take the pass. No, sign out and take the pass. You got to put your name there so when you don't bring the pass back, I know who to hunt down.
Yes, I answered
There's not even a 106 assignment. Why was I so frustrated? Hey, are you guys gonna like physically turn for 106? Or are you just gonna wait?
Can you integrate one of these
No, it's not a mean. It's literally just walking
When we put the kind of census, the P's, we need to, the P experiment.
Okay,
So,
Probably
candidate of one. So just went to the last unit, because we just handed it about the important.
What's the difference between arch and like, yeah,
We take the arctangent of cotangent, then I actually think it's the full progress, which is rounded down a number.
yeah, like arc sine is the inverse.
Are you done? Brendan, are you done?
No, sir.
Okay, I know some of you guys work quicker than others, and again, if you're much quicker than the rest of us, the website has most of these worked out to help you when you get stuck, but it doesn't have the first 4 or number 6. So, has anyone tried question 1 and had trouble coming up with 100 minus 25 pi? Because I can work it out if you need me to. Everybody's okay with number 1? Okay, then for question 2, I got 25 units squared. Anybody that's tried question 2 and did not come up with that? Because I will work it out. Still no? Okay. Let me offer the rest that this would be your only chance to get help on, because these are not on the website. Number 3, I got 26 units squared. Anybody need to see number 3 worked out? Okay. So again, most of those are pretty straightforward, where you didn't need anything new. You just had to use stuff from before. So I think that's good that you guys are okay on those. But then question 4 is the first one that forces you to think about area under the curve. So question 4, I ended up with an answer of 1/6. Would anybody like to see this one worked out? Okay, we'll offer 2 more here, and then I'll give you a few minutes to work before I ask again. Question 5 was all the way down here. Now, question 5, if you had issues with this one, part of the problem is this one does have a couple typos on here. So this one was supposed to say below y equals 5 and above y equals x squared plus 1. So there's like 2 or 3 of these questions that kind of mess up the wording there. But question 5, the arithmetic was certainly messier, but I ended up with 32/3. Does anybody need to see that one? You do?
Yeah.
Okay, so they want me to find the area in between these. Just go ahead. They want me to try to figure out the area in between these. So I know I should be thinking of it as integrating top minus bottom or integrating right minus left, but I don't know which of these two that's going to be. And even if I did, I don't know which one's on top, which one's on bottom, versus which one's on right, versus which one's on left. So what I tend to do is I try to make a quick little sketch here, especially if these are easy enough to think about what the graphs look like. So y equals 5, horizontal line, y equals x squared plus 1, is going to look like x squared shifted up 1. Now, a common mistake that happened with my B-Day class the other day is they were only doing this part of it. You really need to think of the whole graph. So I want the stuff below y equals 5, but above x squared plus 1. So I'm trying to find this. So there's 2 benefits to the graph. It makes it very obvious to me that the top is 5 and the bottom is x squared plus 1. Make sure you subtract the whole x squared minus x squared plus 1, not just the x squared. Put parentheses or just distribute. You subtract the whole bottom part. Because it's top minus bottom, it's dx. This stuff should be in terms of x, which it is. In fact, I'm going to go ahead and combine those because that's kind of silly not to. And then the bounds. So some of the questions just come out and say between this x value and this x value. And some questions you have to figure out between the 2 x values or between the 2 y values. But if you have a graph, you can see this area that's tracked in between those starts off at x equals -2 and ends when x equals +2. So sometimes the graph is going to be enough for you to know what those bounds are, I can see that that's where they're equal to. But occasionally, I didn't need this on this question, but so you guys know, another strategy is to say that if y equals 5 and y equals x squared plus 1, then I can just set those two things equal to each other, and I can solve algebraically. So where they intersect is plus or minus 2. So again, I don't need to do that on this question because I have a visual, but occasionally you need to set them equal to each other and solve algebraically to find those. Okay, so now we can just fall back on the integration part, antiderivative, antiderivative, evaluate from -2 to 2. So plug in 2 the first time, plug in -2 the next time, subtract those, and so I'm going to do, this is where I said the arithmetic's a little messier, but 8 plus 8 would be 16. -8/3 minus 8/3 would be -16/3. If I change this to have a common denominator, this would be like 48. And 48/3 minus 16/3 leaves you with the answer, 32/3. Got it? So my guess would be that you didn't sketch it to see top minus bottom.
I only did the first quadrant one.
Yeah, and that's pretty common. Like, it's easy to just want to think about quadrant 1, but
Yeah.
it's between the whole thing. So, okay. Anybody else that was having issues with number 5 want to ask anything specific before I take it away? Okay, and then one more, just because this is the only other one not worked out on the website, is number 6. Number 6 is this one, and you should get an answer of 1/3 on number 6. Does anybody need to see that one worked out? Yes, okay. Okay, so again, I know I'm trying to find the area trapped between these two, so I know that this needs to either be integrating top minus bottom or integrating right minus left. I don't know which is which, and even if I did, I don't know which one's on the right, which one's on the left, or which one's on the top, which one's on the bottom. So, similar to question 5, I think it's worth taking a minute and trying to, if I can slide over here, trying to sketch a quick little graph of these to visualize. So x squared is definitely the easier of the two. Hopefully my graph is going to be accurate enough for you to see what we need to see. This one's a little harder to graph. But I could find its x-intercepts by setting this equal to 0 and solving, and see that he has an x-intercept of 0 and an x-intercept of 2. What else can you tell me about this graph?
It's like
Okay, it's a parabola because it's second degree, and his coefficient is negative, which means it's going to open downwards. So the area that's between those two is that little sliver right there. So it looks like my purple one is always on top of my red one. So this is a top minus bottom type of question. So top minus bottom looks like this. Top minus bottom is always dx, and these need to be in terms of x. So I can easily see that this x value is 0. I don't have to put too much thought into that. But what about this x value? It It looks like it's probably at 1, but again, to be safe, if this stuff equals y and this stuff equals y, we can set those two equal to each other and we can solve this algebraically to be safe. So add this over, subtract this over. Anytime you solve a quadratic, move everything to one side, set equal to 0. And sure enough, the x-intercepts were 0 and -1. Or I'm sorry, not the x-intercepts, but where these two lines intersect was at x equals 0, which I was sure about, and x equals 1, that I was pretty sure about, but again, to be safe, I went this method. So
X would be 1, not -1.
oh, yes, you're right. I didn't factor correctly. It should be +1. Thank you. Also, before I integrate, we might as well just combine these like terms. Any simplifying you can do is going to make your life easier. So we've got antiderivative, evaluate from 0 to 1. So plug in 1 the first time, plug in 0 the next time, subtract those, and you end up with 1 minus 2/3, which is where I got an answer of 1/3. But again, a lot of the kind of headache to these questions is when you read it, you don't know if it's right minus left or top minus bottom, or you don't know what's on right versus what's on left, or what's on top versus what's on bottom. And you really kind of need to think of them visually, or better yet, just sketch them very quickly. Also, what can be a headache is finding these bounds. So I was sure about this one, I was pretty sure about this one, but you shouldn't be guessing. You can always just set these two equal to each other, and you can see where they actually intersect without just hoping. All right, anything else about this one? Okay, I'll leave this one up a little bit longer, and I'll give you guys a little bit more time to keep working. Again, if you do run out of time in class, the rest of them are all worked out, so any of them that you get stuck on, you can watch the video to help you get unstuck. I don't plan on taking this up the first day we come back from spring break, but I also won't give more class time to work on this after spring break. So you really should finish this up for homework. If you don't finish it up in class, I suspect you guys don't have too much going on in advisory today, or maybe some of your other classes. So try to sneak it in, because you don't want to have to worry about it the Sunday before we return. So okay, so let me set a timer, and then I will ask to see if there's a few more I can help with before y'all go. You still got about almost 40 minutes, so. Just like on the L'Hopital's one, L'Hopital rule circuit that you guys did, there is two things that show up on this that I've never told you you have to memorize. One of them you asked about earlier today. That was the derivative of an exponential function that's not e. So I've reminded you of this one already today, but you do need that again on this one. And another one that I will have to insist you memorize before your AP exam, but you have not been tested on it, is you also need to know the derivative of inverse tangent. One of these questions is 8 times that, and there's no other way to integrate it than to do that. So make sure you jot those down to the top of your page so that you can look at them when you need them. Is that enough to get you past that? Okay, so inverse tangent of 1 just means what angle has a tangent value of 1. So you gotta think about unit circle, sine over cosine. Yeah, but your answer there is just gonna be an angle. Yeah, and then inverse tangent of -1 is the angle where tangent is negative. He's got one I can help with. Number 7. Oh, so, well, 2 things. The mistake that you have, I also had it first. So right here, this isn't 0 to pi over square root of 2 over 2. What angle is that? Yeah, that's 3 pi over 4, so let me change that. That's where those are equal. Okay, so when you plug in pi over 4, this stuff goes to square root of 2 over 2 plus square root of 2 over 2, which gives you 2 thirds, 2 over 2, and square root of 2. But you also have to plug in 0. And when you plug in 0 into that, one of those goes to 1. And that's what we're so used to 0 just going away, but we'll go over that. Okay, you guys have one I can help you get past.
I got the answer.
Oh, no, I'm here. I just didn't know.
No, that started recording. What I did is I found the area of the photograph area. And then I found the difficulty between the highway area and the area.
Okay, so the problem is, this is kind of if you're integrating from 0 to 2. Okay, well, first off, the area you're supposed to be finding is this. This is this stuff between.
That's why.
Okay.
Oh, this is
But is this where y equals 5 stops? It doesn't go on forever? Okay. Doesn't this keep going? There's double it. So you should have integrated from -2 to 2, or based on the symmetry, because this area equals to this area, you could double it. Or, sorry, 32.
That makes sense.
So pi over 4, so, okay, and then 0. So we plug in 0, what's the sine of 0? Okay, and we plug in cosine, that would be not a 0. Cosine of 0. Okay, I agree.
Oh, that's
And so, and then all you need. Okay, so back here, is this top minus bottom?
Oh, wait.
It should be top minus bottom, so then when you integrate, that minus sign becomes a plus sign. See what I'm saying?
Yeah.
Top minus bottom, and then this becomes exactly like the plus.
Pretty much. No, whatever is the
Well, if you graph sine and cosine, this should say to the right. So to the right of this, and then try between us, it's like a triangle. The tricky part though is the bound. Obviously it starts at 0, but you have to think about where would sine and cosine be the same. Remember that from unit circle?
Zero and five.
Well, actually.
Well, so this just means like sine of 0. What is the sine of 0? Okay, and then square that. And then 4 times that.
Because type of sine is 0, cosine is 0.
Would that be something I can help you get stuck on? Help us? Okay. What does the sine and cosine graphs look like? Also, this one's a little harder because there's a typo here. This is supposed to say to the right of the y-axis. So here's what the picture should look like. To the right of the y-axis, we got this. So this is the top one's the cosine graph, the bottom one's the sine graph. But your bounds are going to be 0 to this one, and then you have to think about where sine and cosine are going to be. If you have one I can help with. Number 7. Yeah, well, part of it is, this should say to the right of the y-axis, so that part's a little confusing. So this is the area you're trying to find.
One of them has to be
Correct, yeah. So the y-axis is, that would be x-axis if you were doing that. And the problem with the x-axis is it would be like some area here, and then some more area over here, and some more area over here. Yeah, the answer would be infinity, because it wouldn't stop. Okay, and then so for the bounds though, it's pretty easy to see that you start at 0, but then where they intersect, you have to think about where sine and cosine are the same values. So you gotta think about the unit circle and how they're both the same at pi over 4. I think when we come back from spring break, I think there's only 3 more question types that would be completely new to you. So we are pretty close to just being able to review for the AP exam. Have y'all started reviewing in any of your other AP classes?
We're still covering chemistry.
Well, I mean, we're still going too. Have they mentioned when you're gonna start doing an AP review? Like, if you'll get 2 weeks of AP review, or? They haven't said.
He's probably said something and I just forgot.
Is it just?
Just like, they give you the bounds.
But if yours here, and did it all in one order.
One is higher, right, for that. And there's 4 with approximately.
Oh, so we stack it all. Oh.
Yeah, you should know.
back up there. It's the second one. I think I'm up to level 103 now. I found the ice place, but it's like in the distance, so I haven't gotten it back yet. I just got the capital finally. The guy blocking it was giving me issues, so. I just, like when you fight harder people, you just like try it 20 times. I usually like try it 3 or 4 and I'm like, out, just come back. My game is way too fast. Elden Ring. I still haven't done anything with all the rooms I collect though. What do you do with them? Do you sell them or? Yeah. That's all you do.
Yeah, that's-
Oh, okay. Well, I've got a ton of films. I've been scared to use them. Hopefully I'll finish it. I'm getting a little tired, like I was enjoying it, but I'm tired of just playing that type of game. But I know if I start something different. Okay, now that's good.
All this, so that someone can tell me that I'm trying.
Did you said you played Bloodborne too? Which one do you like better?
Because I am trying.
I think I'm gonna try Bloodborne again soon, now that I feel like I can use this one. But, maybe the show sounds.
Oh, there too. Yeah.
All right, guys, you've got about 8 minutes, so hopefully time to finish up another question, maybe 2. Again, I know you're close to break. You guys are ready for all of that, but please try to finish this up today. You aren't going to want to do it at the end of spring break, and you don't want to come back from spring break feeling like you're behind. So try the rest of it. Any of them you get stuck on, the videos on the website should help you get unstuck. This will be one of the topics on your last unit test for us, so you might put stars by the ones that gave you issues so you know what to look back at. But when we come back from spring break, again, we've got about, I think it says 3 new question types you haven't seen, and then we can focus on reviewing stuff from last semester and practicing FRQs and all of that kind of stuff to get better prepared for the AP exam. What's your hand up?
Yeah, I just messed up somewhere in here. So, this probably.
Oh, that's fine. Where's your second part?
So this is to do with this part, and this is just like with this part.
Okay.
And so this came up here as in state grade. This one up here. This is your choice. And then this is this, and this is this.
Why would this, why would negative x greater than x squared?
Oh. Because
I think
that's, because I rearranged it.
oh, this is,
This is your x became x squared. Now you're going to try to make it and it's sort of
so I have all the same stuff, 0 to 1.
0 to 1.
Here's another.
It's 1 plus x cubed plus 1 plus x cubed minus x squared.
You might just circle it and try it again later, I don't know.
Yeah, I'm just gonna.
It should be presented well.
Yeah, I figured because I got 85 votes and the closest there was 37.
So if you set square root of x equal to 1/2 x,
I isolated y. And I bound to a 1 and one for everyone down to 1.
at some point you need to square this,
Because if you.
which means you're gonna square this. And now it's like a quadratic, and that's where the second one's gonna come from. Factor out an x.
Whatever you did, good job.
And so this is 0, and then when this is 0, which is add 1, add 4, I guess 4.
I didn't know if I could set them equal to each other.
Yeah, if this is equal to y and this is equal to y, if they're equal to the same thing, then you can set them equal to each other.
Thank you.
And then that's the algebraic way to figure out where they intersect.
Yes. Yes.
Yeah.
All one circle.
Most of these had a solution that does not exist.
That one and what else?
This and
I disagree with that one.
Okay, how so?
Well, your numerator looks like you factored.
Well, I took the derivative, factored that.
Well, the derivative would be 6x plus 5.
Yes. And
Why is there an x plus 1?
Because the derivative of the natural log of x plus 1 squared.
Would be 1 over x plus 1 squared times the derivative of x plus 1 squared because of chain rule. That's a real messy way to go
Isn't
about
it
that.
2 times the natural log of x plus 1 divided by x plus 1, which, because it's in the
Okay.
denominator, it would be flipped to 6x
Okay,
plus
so
1.
if you flipped it, then why is it also down there?
It's 6x plus 1, or, well, nothing. It's 2 times the natural log of x plus 1 divided by x plus 1, but the denominator is flipped, so it's x plus 1, and then the numerator, and this is the denominator.
I'm saying I agree with bringing the 2 down. I think that's a good idea.
I double checked it before.
Okay, so this is what your denominator says. Right? What's the derivative of this?
2 natural log of x plus 1.
So 2 times, what's the derivative of this?
1 over x plus 1.
Okay. Now, if you want to say dividing by this is the same as multiplying it up there, that's fine, but it's not down here anymore, and it's not natural log anymore once you took the derivative. So leaving this in your denominator is what's causing your issues.
I double checked this.
I don't know, unless there was something else that had changed also to keep it balanced.
I took it as, was it the natural log? Was it the natural log of this squared or the natural log of this squared?
I would read this as just the x plus 1 is being squared.
Okay, I took it as the natural log being squared.
If for that to be the case, I think there would need to be another set of parentheses to show that it was all of it.
Okay.
Alright guys, y'all need to start getting your stuff together. It's about time to go. Have a nice break.